All right, the last part of chapter 9, which is part 4, we're going to talk about reaction to fats, just kind of understanding a little bit about oxidation and those kind of things, and some of the negative things that happens with fats. So one of the things we can talk about with fats is rancidity now. They can go through several different types of rancidity. So it may be hydrolytic, it may be oxidative. So first we're going to talk about hydrolytic rancidity. So obviously the triglyceride is made up of the fatty acid chains that are attached to your glycerol. But specifically, you're talking about the C4 butyric acid, where the short chain fatty acids really become the real problem. And because there might be the presence of certain enzymes in wherever they're at, and that's lipase. So anything with ASE on it is an enzyme, and it's meant to break down the thing that's before. So lipase breaks down lipids. So that becomes the real big problem that basically through hydrolysis, it actually starts to break down those fatty acids. But also fats can go through lipid oxidation. Again, that's a major flavor problem we find in food, especially when they're stored for a period of time, and that's due to the oxidation of the lipids that are there. So it all comes about in a free radical reaction system, and it occurs in three phases. So the first, it's initiation of the oxidation, and then propagation, and eventually termination. So this is the possible mechanism for pentane formation from linolenic acid. So we have basically the initiation. Again, here's a free hydrogen. Again, it's able to donate its electron, which you can see right there. So the crazy thing about this linolenic acid is, what does it have? Double bonds. And that double bond, those double bonds make it more conducive for that hydrogen to want to combine with it. Okay. So once it does, it goes through propagation, and you can see as a result of breaking, where does it go for that first double bond? Okay, it's gone now. And what does that release? Oxygen. Okay, so that's why basically we're thinking about the mechanism for oxidative rancidity. Okay, and it eventually going to go through again more propagation. Here comes another hydrogen that's ready to go, and can basically look at another type of double bond. So basically, it's that it repeats this over and over. So then, one of the things that you'll find is some of the odors that you get with stuff that has you think has gone sour or bad, and typically that's just because of the auto-oxidation of those double bonds there, and most of the time that smell is a peroxide smell. So you can see hydroperoxide decomposition. Okay, so we're actually going to lose an OH group this time, and then eventually, what really gives you that true oxidation is the pentane that's formed. So basically, it's going to cleave off. You can see part of it, which then will become the pentane with that liable hydrogen atoms that is just in the balance here. So this just shows you the whole step of the last couple of slides all together, and how it actually does form. So all the way from initiation and then the propagation and then the actual termination with development of pentane. So we can also look at the analysis of flavor quality and flavor stability of oil, and all that has to do with the peroxide value of it. So again, there's the chemical reactions you can kind of see, quite a bit of them, but the biggest thing we're trying to measure is, again, that peroxide value, the ability to form those peroxy type of attributes that would lead to oxidation. There's also the active oxygen method, which is it's basically determining the time that's required to obtain those certain peroxide values under a specific experimental condition. But the larger the AOM or active oxygen method value, the better flavor stability of the oil. So it's not going to be broken down as much. So they can look at that in terms of they're going to market a new type of oil and look at the active oxygen method and say, is it going to break down quickly or not at all? And also, again, we can do the TBA test, which determine the rancidity degree, especially on meat or fish. And so, again, when they would use that TBA method, they can actually get a color pigment, which can tell you what is the stability of the oils that are or fats in that product. All right, that's the end of chapter 9.4. Complete any quizzes in this section, and then you move on to your last parts of food chem, which is chapter 10.